This video will look at the cumulative normal distribution as given in Figure 6.13, which considers the cumulative normal probabilities for the birth of newborns. Suppose, for example, that we knew that the average weight of newborns was 3,600 grams and the standard deviation for the weight of newborns was 850 grams. If we assume that the weight of newborns was normally distributed about the mean, could we say anything about the likelihood, for example, of a birth of less than 2,000 grams, or a birth less than 1,000 grams, or a birth greater than 8,000 grams? That's the kind of question we can address with the cumulative normal distribution. To begin the discussion, I'm going to put in standard deviation units, and I'm going to go all the way from minus 3.5 to 3.5. So these are the standard deviation units. Now here I'm going to put weight of newborns, and here I'm going to put weight, and here probability. Now I said that the average weight for newborns was 3,600 grams, and the standard deviation for newborn weights is 850 grams. So, if I say that this weight is equal to the mean, fixed with an F4, plus the standard deviation unit times the standard deviation itself, fixed with an F4, I see that the weight at minus 3.5 standard deviations is 625 grams. If I click this down, I have the weight at the various standard deviation units from the mean, and here is the mean weight of 3,600 grams. Now, to find the probabilities, I use the equal norm dist function, and x is, in this case, 625 grams, and it will change as we go down the column of weights. A comma, the mean is 3,600, fixed with an F4, and a comma, and now I need to get the standard deviation, fixed with an F4, a comma, and now for the cumulative distribution, a 1. There is the probability that a birth will be 625 grams or less, and I'll click this down, and here is the probability that a birth will be 6,575 grams or less. So originally we said, what's the likelihood that a birth will be less than 2,000 grams? The likelihood that a birth will be less than 1,900 grams is 0.02275. But let's look at 2,000 grams. I'll just type in 2,000 for the x value, the mean, comma, standard deviation, comma, 1. So the probability that a birth will be less than 2,000 grams is less than 3%. If we assume a mean of 3,600 grams, standard deviation of 850, and that births are normally distributed. What's the likelihood that a birth will be more than 5,300 grams? Well, here it says that the probability that a birth is less than 5,300 grams is 0.977. So the probability that a birth is more than 5,300 grams would be equal to 1 minus the probability that it will be less than 5,300 grams. And that turns out to be 0.02275, which is exactly the same as the probability that it will be less than 1,900 grams. Using this cumulative normal distribution, it's possible to find the probability of a value less than any point in the birth weight sequence by simply looking at the probability itself. It's possible to find the probability of a birth weighing more than any point in the sequence by taking the point of interest and subtracting its probability from 1.